Hello friends. Uh, Today we are going to discuss here one question. That question may be asked in the interview. Generally, whenever you are going to face the interview after your graduation, if you are giving your introduction as okay, so sir, I have graduate in the electrical engineering, and then the person will be asked you the question. Do you know the transformer? And your answer will be yes. Do you know the induction motor? Your answer will be yes only. And now the interview will ask the question why the induction motor is called as generalized transformer. Again, I will repeat the question. Okay, why the induction motor is called as generalized transformer? Okay, the answer is that there are something say two similarities. There are similarities in case of operation of induction motor and transformer. How the induction motor is working? Okay, in case of induction motor, if I am considering here the three-phase induction motor or single-phase induction motor, let us consider here the three-phase induction motor, and the induction motor is connected in the delta fashion. So whenever we are going to give here the supply to the stator winding, okay, so it produces here the rotating magnetic field on the, yes, it is on the stator side. So this rotating magnetic field is getting interacted with the rotor circuit, and due to the induction principle, the EMF get induced in the rotor winding. Now, if I am considering here the squirrel cage induction motor, then okay, so rotor will be something say the rotor bars are shorted on the both sides. Now here, okay, so the EMF get induced across the rotor winding, though the magnitude of this EMF is very less, like say it may be around 2 volt. If I am considering here the initially the induced EMF is a 2 volt, or say it may be say 10 volt, then the rotor winding has very small resistance. Like suppose the resistance of the rotor winding is say 0.5 ohm, then 10 divided by 0.5, okay, so around like 20 ampere current will pass through the rotor winding, and this winding current or this current is something say getting produced, or say it is started to flow through the rotor winding. It is having the tendency to produce its own flux. Now there are two fluxes in the air gap. One flux is produced by the stator winding, one flux is produced by the rotor winding. There will be interaction of these two fluxes, and finally the torque get produced on the rotor, and okay, so rotor starts rotate here. In case of transformer also, okay, so whenever we are considering here the transformer to the primary winding, we are going to give here the supply. Actually, the transformer works on the principle, okay, again it is the say induction principle only. So when we are going to give the supply to the primary winding, the EMF get induced in the secondary winding due to say mutual induction principle. Means in the secondary also the EMF get induced here, and this induced EMF, okay, so depending upon the turns ratio, the EMF may be different here. Suppose E1 is equal to, I can write down here the formula for the E1, or say we can state here the formula for the E1. E1 is equal to 4.44 F phi m into N1. So what is F here? F is supply frequency, phi m is the flux in the core, it is maximum flux, and okay, so N1 is the number of turns on the primary side. Similarly, I can have the induced EMF in the secondary also. So E2 is equal to 4.44 F phi m into N2. So both are the sinusoidal quantities. Once I have the value of N2 and the N1, in the proportion of that, you can get here the value of E2 and the E1. So similarly, okay, so here the power transfer from primary to secondary is due to induction principle. In case of induction motor also, power transfer from stator to the rotor is again something say based on the induction principle only. So that's why the induction motor is called as generalized transformer. What are the dissimilarities here? The dissimilarities are, okay, so induction motor has the stator winding, transformer has a primary winding. Okay, so primary winding can be treated same as the stator winding, but in case of rotor circuit, of the induction motor, the rotor is rotating, but in case of transformer, the secondary winding is not rotating. So that is actually difference. So transformer is a static device, and induction motor is a yes, it is a rotating device. Okay, so in this way you can convey to the okay, so that interview person. Thank you.